Alright, so today we're going over tangent and velocity in calculus. So some main things to note in this section is what a tangent is. A tangent is when there's two lines and they only meet at one point, which could also be interpreted as the instantaneous velocity or the derivative at that point, the slope rather. So another thing to note here is the velocity, which is essentially the speed at any given point or the derivative of the position equation. So the last thing is the average velocity equation, which would just be change in position, which could be displacement or how much the change in position over the time. That would give you the average velocity. Alright, so how we'll do this is we'll do 3 questions together and then I'll have you guys do 3 questions by yourselves. So the first question is, a tank holds 1,000 gallons of water which drains from the bottom in half an hour. And V is the volume of water remaining, which is down here, and then T is the minutes that surpassed since it started draining. So A is, if P is the point 15, 250 on the graph of V, find the slopes of the secant lines PQ when Q is the point on the graph with T equals 5, 10, 15, 20, 25, and 30. So for this question, we have to reference everything off of this little point over here, 15-minute mark. So let's use the equation from the beginning, the average rate of change equation, or rather the slope equation. So in order to find the slope at from 5 minutes to 15 minutes, let's do 250 gallons, because that's how much was left at 15 minutes, minus 694. That was at 5 minutes, and then on the bottom we would do 15 minus 5. And now that would just give us, on the bottom would be 10, and on the top we would have negative 444. Now if you make that even smaller, we get negative 44.4, which that would be the slope of the line PQ when T is equal to 5. It's essentially, if we draw the graph of it, let's say this is 5, 10, 15, 20, 25, and 30. 1,000 gallons is up here. Let's say it starts with 1,000. Then at 5 minutes it's 694, 444, 250, 111, and then 28 gallons, and then this is where it drains. So that's how the graph looks. So you can see negative 44.4, the slope. It kind of checks out. It would be from here to here. That would be our secant line. So let's try it with T equals 10. If we do the same average rate of change equation, we'll again do 250 minus, let's do 10, which is 444 gallons, over, and this will be 15 minus 10. So at the end we'll have 5 in the denominator, and in the top we will have negative 194. Now if you simplify this further, we will have negative 38.8 as a slope from 10 minutes to 15, which is our PQ line. So it would be this line right here, the 10 minutes to 15, negative 38.8. It kind of checks out, it's going down, which means it's negative. So and you would do the same thing for 20, 25, and 30. They would all be negative, but it would be gradually decreasing. So let's go to B. Estimate the slope of the tangent line at P by averaging the slopes of the two secant lines. So for this, all we need is the slope from 15 to 20 and 10 to 15. because they are the two closest points to 15. So we already know the 10 to 15, that's negative 38.8. We have to find the 15 to 20 slope. So if we do the average equation again, we'll do 250 minus 111, and then down here we'll do 15 minus 20. So afterwards we will get negative 5 on the bottom, and then on the top we will get 139. And if you simplify that further, that would give you negative 27.8. So negative 27.8 is the slope from 15 to 20. And now what we do is we average the slopes together. So let's put together 38.8 and 27.8. If we add that together, that would give us negative 66.6. And now we just have to divide that by 2 since we're finding the average. Now if we divide it by 2, we get negative 33.3. So negative 33.3, that is the average of the two secant lines nearest to P, which is this coordinate right here. So that would be the answer for B. And for C, the question is use a graph of V to estimate the slope of the tangent line at P. This slope represents the rate at which the water is flowing from the tank after 15 minutes. Now we already kind of drew a graph here. Of course you could draw it in a like more upscale fashion, like a bigger one, to better, you know, figure out the slope of the tangent line at P. But through the calculations, even by like if you drew like a physical graph, it would still come out to like around 33.3. So from the like mathematical perspective, that is gonna be like the right answer there. But this question is asking us to draw a graph, like a physical graph, which something like what we did up here, except you just move it down here. Alright, so now we move on to this second question. So the question is, the deck of a bridge is suspended 275 feet above a river. If a pebble falls off the side of the bridge, the height in feet of the pebble above the water surface after t seconds is given by this equation. So this equation is going to be really important. So A is find the average velocity of the pebble over a time period beginning at t equals 4. So for this question, t equals 4 is kind of like our base point. It's what we're gonna base everything around. So we need to find the average velocity from 4 seconds to 4.1 seconds. So this is the position graph. This is the position equation. So in order to find the velocity, all we need to do is to find the derivative of this equation. So what is 16t2 plus 275? In order to find the derivative of this equation, we'll just use the power rule. So we'll end up with negative 32t, and then since this is a constant, this gets crossed out. This is our equation that's going to be really important to answer A. So now all we need to do is just plug it in, simple as that. These are t, so if we plug it in 32 and we plug in 4.1, and then for 32 we plug in 4 seconds, that's 0.1 second gap. So this would be 128, and I believe this would be 131.2. So now it says find the average velocity. So since this is the velocity of 4.1 seconds, this is the velocity of 4 seconds, what we have to do is add these together and then divide by 2. So if we add them together, it gives us something, and then when we divide by 2, we end up with 129.6 feet per second. So this is the answer to the this question right here, I. And the answer to the second part, we'll do that right now. So since we're basing it also off 4 seconds, first point will be at 4 seconds, and then the second point will be at 4.05 seconds. So for this, we'll still use the velocity equation. So all we need to do is just a simple plug in 32 times 4 and 32 times 4.05. So for 32 times 4.05, we end up with 129.6, and for 32 times 4 is 128. Funny enough, the 4.05 is the exact same as the average velocity of the first one part. So for this, in order to find the average velocity, we just do the same thing. We add them together. So if we add them together, it gives us 257.6. And if we divide that by 2, we get 128.8 feet per second. So for the second part, this is the average velocity of this gap, 0.05 second gap. We'll skip that and we'll go to B. So for this, we have to estimate the instantaneous velocity of the pebble after 4 seconds. Now the good thing about this is that we have the instantaneous velocity equation, which is 32t. So for this, we could estimate it. As you see, the numbers goes down, it goes closer to 128. But also, if we plug in 32 times 4, t as 4, it just gives us 128 feet per second. So it's just a simple plug-in, and that's how you do B. Alright, now I want you to try this question by yourself. So you could pause the video and try it out, and I'll start answering in a few seconds. Alright, so this question is it is showing us a position of a motorcyclist after accelerating from rest. So A is asking us to find the average velocity for each time period. So we're given all this information here. So in order to find the average velocity, let's find it from 2 to 4. So remember the average velocity equation we looked at the first slide. We would just plug in 79.2 minus 20.6, and then just 4 minus 2 on the bottom. So when we do that, we get we get 58.6 on the top, and then we get 2 on the bottom. And if we simplify it even further, we get 29.3 feet per second. So that is the average velocity from 2 to 4. And now let's try from 3 to 4. So for this, it would just be 46.5 minus 20.6 over 3 minus 2. So on the bottom would be 2, on the top would be 25.9, I believe. Yeah, I believe so, 25.9. So your final answer would be 25.9 feet per second. And let's skip the third one. Let's just do a fourth one. So the average velocity for this would be 4 to 6. That would be 176.7 minus 79.2. And on the bottom would be 6 minus 4. So on the denominator would be 2, and 176.7 minus 79.2 would give you 97.5. And if we simplify it further, we would get a velocity of 48.75 feet per second. So these are the three answers for the first, second, and the fourth one. And now if we go on to B, it says use the graph of s as a function of t to estimate the instantaneous velocity when t equals 3. So we kind of have to guess the velocity of this based on kind of our answers here. So we do know from 2 to 4 the average velocity is 29.3. Now we found it from 3 to 4. Now what we could do is find the average velocity from 2 to 3. That would help us. So if we find the average velocity from 2 to 3, we would do 46.5. Hold on. Oh, my mistake. Over here I did it from 2 to 3. So let's just switch the question there, 2 to 3. So we need to find the average velocity from 3 to 4 in order to help us get the answer to B. So from 3 to 4 it would be 79.2 minus 46.5, and then on the bottom would just be 4 minus 3. So 79.2 minus 46.5 is 32.7 over 1. That's it. That's the velocity from 3 to 4. And we know the velocity from 2 to 3. So if we grab 25.9 and then 32.7 and we add it together, we would get 58.6, which we have to divide by 2. That would give us 29.3 as the instantaneous velocity from at t equals 3, which funny enough is the answer from 2 to 4, because that's all the information we're given. So you could have just put this answer there, but you could also go through his math just to verify that it is 29.3 .3 feet per second. Alright, so I want you guys to answer this question by yourselves, and you could pause the video. I'll give you guys the answer in a few seconds. Alright, so this question is, if a rock is thrown upward on planet Mars with a velocity of 10 meters per second, its height in meters t seconds later is given by the equation y equals 10t minus 1.86 t squared. So for A, we have to find the average velocity over the given time intervals. So we know that its height in meters refers to the position, so this is the position equation. So in order to turn this into a velocity equation that will help us for A, we just find the derivative of this. So the derivative of 10t is just 10. Using the power rule, we will take out t, and then the derivative of this is 1.86 times 2, so 3.72 t, because you would bring the 2 here and multiply it with the power rule. So this is our velocity equation. This equation will help us find the answer for this. So for this, we could just use the average average equation that we talked about. So we would just have to do some plugging in here. Okay, so what I've done is I've given us all the numbers instead of waiting to calculate it here. I just wrote it down. So let's do this question now. So find the average velocity over given time intervals. For the first one, it's 1 to 2 seconds. So we know at 2 seconds it's 2.56. and then the at 1 second is 6.28. And then on the denominator we have just 2 minus 1. So on the top we would get negative 3.72, and then on the bottom would just be 1. So negative 3.72 is the average velocity over that given time interval. So let's try to do all of these. So the second one is 4.42, because it 1.5 seconds is 4.42, and then minus just 6.28 over 1.5 minus 1. So if we do the math there, that would be negative 1.86 over 0.5. Now if we simplify that, that would just give us negative 3.72, which it's kind of the same as the first one. Let's skip to 4 real quick. So let's find the average velocity for this. So it's 6.2428 and minus 1, which is 6.28. And then on the denominator it would be 1.01 minus 1. Now if we do the math here, that would give us, on the top it would give us negative 0.0372, and then on the bottom we would get 0.01. Now if we simplify that, that would just give us negative 3.72 again. So you see kind of a trend going on here. The average velocity is kind of staying the same. Alright, so from the instantaneous velocities of the other intervals, all near 1, we could kind of estimate that the instantaneous velocity at t equals 1 will also be negative 3.72. So that is the answer to that question. Alright, so I hope you guys, understood this little section of tangent and velocity in calculus. And always remember the average velocity equation and what is a velocity and what is a tangent line, as well as the secant line. Secant line is just a connection between 2 points. So yeah, that's basically it.